Welcome to our lesson on inscribed polygons. So by the end of this lesson, you should be able to find the measure of angles and arcs involving an inscribed polygon. You'll also know what an inscribed polygon is. So we're going to start off with a theorem. Given two chords of a same circle or of congruent circles, if the chords are congruent, then the arcs created by each chord are also congruent. The converse is true too. So what this means is here I have two congruent circles. I know they're congruent because they each have a radius of 3. Any chords that are part of congruent circles, so in here, this red chord, those are marked congruent. That means that those arcs that are created by them are also congruent. And there's a reason for this. So if we draw in a radius from each end of these chords, right, because it's a radius, they're each going to be 3 long. And we know that we can show triangles are congruent by side, side, side. Each of these triangles have two purple radii and then the congruent chord. So we have side, side, side congruence. And if the triangles are congruent, that means their corresponding parts are also congruent. So that angle, the central angle that is created by the two purple radii, are going to be congruent. If that angle in the center is congruent, that means that the arc created by that angle is also congruent because of central angles. What does this really mean for us, and what does it look like in practice? So here's an example. Find the measure of arc FG. So these two circles are congruent because both radii are marked congruent. And then we have the chord JK and FG marked congruent. Because we have congruent circles and the congruent chords, that means that the arcs are congruent. So if JK is 80, FG is also 80 degrees. If arc AB is 110, so this is 110 degrees, find the measure of arc BC. These chords are part of the same circle, so we're good there, and the chords are congruent. They're both 9. That means that they have congruent arcs. So BC is also 110 degrees. But here's a different type of problem. This tells me that arc AC is 150. And it wants us to find AB, that arc. Well, there's no relationship between an arc by the chord versus not. But we do know that congruent chords make congruent arcs. So if AB is X, BC must also be X, because those arcs are created by congruent chords. Now I have all 3 pieces of my circle with some sort of value to it, and I can write an algebraic equation. 150 plus X plus X, so those are the 3 pieces of my circle, equals 360 degrees, because it makes the full circle. Subtract 150 and combine my like terms. So 2x equals 210, and then divide by 2. X equals 105 degrees. So arc AB is 105, and arc BC is 105. Okay, but let's look at some polygons. Remember, the purpose today was to be looking at polygons. So here is a circle, and we have a square inscribed here, okay, drawn inside with the vertices on the circle. Find the measure of each of the smaller arcs. Well, remember, congruent arcs, congruent chords. Because a square has 4 congruent sides, we know that we are splitting this into 4 congruent arcs. X plus X plus X plus X equals 360. Combine like terms, and then divide by 4. X equals 90 degrees. So each one of these arcs would be 90 degrees because we're taking a circle and dividing it into 4 congruent pieces. Same type of problem, but now we have a hexagon. So a hexagon has 6 sides, but it's still a regular polygon, which means it has all congruent sides. So here we have 6 congruent chords inside my circle, and that just means that we have 6 congruent pieces of my circle, or 6 congruent arcs on the outside. So if I take all these, add them up, I get 6x equals 360. 6 sides for the hexagon and a full circle 360. So solve for x by dividing each side by 6, and x equals 60 degrees. Why don't you take a moment and see if you can do a non-gon, which is a 9-sided figure, but try to do it without drawing the shape. Hit pause. Okay, so to do a non-gon, or any shape, it's the number of sides times x equals the circle, 360. Divide each one by 9. X equals 36 divided by 9, 40 degrees. You may also have said it's just a circle divided by the number of sides, and that would be correct too. Okay, so one way to look at inscribed polygons is when we have regular polygons, so those congruent chords. But what if I don't? First of all, a polygon is inscribed if all of its vertices lie on the circle. And then the circle is said to be circumscribed around the polygon. So a circle is circumscribed outside, and the polygon is inscribed inside. So let's look at a few different types of problems focused more on finding arc measures and angle measures combined. So find the measure of the indicated arc. So we're trying to find this question mark that relates to arc RS. And they give us the angle 78 degrees. 78 degrees is an inscribed angle because the angle, the vertex of it, is on my circle. So I'm going to trace out my angle so I can find the intercepted arc. So here is our angle, and the intercepted arc is between the 2 sides of my angle here. So that whole length. Inscribed angles, when you double it, you get your arc. So 2 times the angle equals my arc. 2 times 78 equals the arc. And 2 times 78 is 156. So the whole arc is 156 from S all the way over to Q. But I know part of this is 80 degrees. So this part here, PQ, is 80. And we want to find RS. So we can use subtraction or that same idea of segment addition. If I was to draw this out as straight lines, I'd have the red part, green part, and the purple goes all the way across. So now you can see the segment addition. Red plus green equals purple. So let's write that as an equation. 156 equals Y for red plus 80, the green part. Solve for Y, just subtract 80. So 76 degrees equals Y. And that's the measure of the unknown arc. So here's a different one. This one has an algebraic expression, but we're going to have the same premise. So the first thing we're going to do is identify the inscribed angle and the intercepted arc. So let's trace out our angle and that's going to be angle Y because that has an algebraic expression associated with it. And so this would be my intercepted arc. MX is my intercepted arc. So if I take my angle and I double it, that gives me my arc. 2 times angle equals arc. So my angle is 6 plus 4x, and that's going to be my arc. Distribute my 2. So the measure of my arc is 12 plus 8x. And we don't know x yet. But we do know that it's 12 plus 8x. But once we do know x, we'll be able to find the arc. So the other piece of this problem here are these measures 90 and 170. And when I color those, you'll notice that we've made a full circle between the red, the green, and the purple. So we can take these 3 measurements and add them up to equal 360 because the 3 of them combined, red, green, and purple, make a full circle, which is 360. So 170 plus 90 plus 12 plus 8x, and that equals a full circle of 360. So I'm going to combine my like terms, add 170, 90, and 12 to 72 plus 8x equals 360. Solve by subtracting 272 from each side. 8x equals 88, and then divide by 8. So x equals 11. And that's all we would need to do. I know it says to find the indicated arc, but it actually just wants us to solve for a variable. That's a typo on my fault. I'm sorry. Okay, so let's now look at some polygons that are inscribed, but they're not regular polygons. So we looked at regular polygons. We kind of looked at polygons with inscribed angles, but let's look at another special fact about quadrilaterals specifically. So the opposite angles of an inscribed quadrilateral are supplementary. So what that means is the measure of angle J plus the measure of angle L is 180, because J and L are completely diagonally across. They're opposites. And the same thing for K and M. Those are opposites. So when I have an inscribed quadrilateral, this only works for quadrilaterals, not for any other shape. Those opposite angles are going to be supplementary, which means they add to equal 180. So let's practice here. Find the value of each variable. So we're going to look for opposite angles because this is an inscribed quadrilateral. So here's a pair of opposite angles. So those are going to be supplementary. So I'm going to add them up. 75 plus y equals 180 degrees. Solve for y. Y equals 105 degrees. And then I'm going to look for the other pair of opposite angles. Q and S. Those are also supplementary. So 80 plus x equals 180. Solve. X equals 100 degrees. That's all there is to this. An inscribed quadrilateral, the opposite angles are supplementary. So I'm going to give you guys a moment. I want you to hit pause and try this one. Look for those opposite angles, add them up to equal 180. Go ahead, try it out. All right, so let's look this over. So our opposite angles are T and V. So 10x plus 8x equals 180. Combine like terms and divide. So x would equal 10. And my other set would be S and U. So S is C plus U. 2C minus 6. They're supplementary, so they equal 180. Combine my like terms. Add 6. So 3C equals 186. And then divide each side by 3. So C equals 62 degrees. So it's all the examples. Let's just wrap a few things together. Congruent chords means congruent arcs, but they have to be inside of congruent circles or the same. Don't forget that. Okay? And this means that with regular polygons, if you take 360 degrees of a circle and divide it by the number of sides, that's going to give you the measure of each of those arcs because you're dividing it by congruent sections. And inscribed quadrilaterals, remember that their opposite angles are going to be supplementary, which means they equal 180. And that's the end of our lesson today.